Part 2 on the VP Tiki bird. So far, I'm going to start off by just showing you this. This isn't done yet. I need to tighten this and get washers and stuff like that, but this is the CNC part I got. Later on, I'll show you how to get something CNC like this. This part only costs, I believe, under $80 shipped from JLPCB. I'm going to show you the whole process. Finishing quality isn't as nice as when I ordered stuff from PCBWay, but I could have had it sandblasted and anodized or done all the fancy stuff. I just wanted to be cheap with it because it's not going to be seen. Overall, the quality was nice and the tolerances were nice, like it worked perfectly. But you have to account for tolerances when you 3D model if you want to have something made. This is the base I had. This is going to allow for a 30-degree rotation on each side. I'm going to show you how to do the math on a lever to find the right length with a stroke length of the cylinder to actually make it rotate 30 degrees on each side perfectly. This is the base I had 3D modeled. It ended up pretty nice. Engineering is a lot about revisions. So here are all the prototypes to actually get a working one. It takes a few times. Even with measurements, you're still gonna get stuff wrong. So it's nice to account for having to redo it until it's perfect and having that extra patience. The base itself is made out of 3 different parts. It's going to be this main base and these little bushings to allow the M4 screws to mount on these little holes, because these are just Servo City build, I believe it's called, parts. They use them for like robotics competitions and like STEM stuff, but they're all aluminum and pretty nice, so I thought I'd just use them. I'm going to thread these at M8. It's harder to thread stuff at home, so if you can, it's nicer to have them do it. And I'm going to show you how to do it. You just need to use a engineering drawing. I have not completed any formal engineering schooling, so you probably, if you want to actually do it, watch other tutorials, but I'll give you a good base on how I do it, which is not the right way. I just want to make sure y'all understand I'm not doing it perfectly. I'm just doing it good enough to get it done, and I don't know. It's not that important to do everything perfectly. Sometimes it's just like the ends is what really matters, if that makes sense. Okay, this part might be a little boring to some of y'all. I'm sorry about that, but it's going to be really useful for some of y'all. This is just me showing I need an M4 screw, and I'm going to find the most common pitch, which seems to be a 0.7 millimeter, and that's the actual length of the thread. This is me showing y'all a through hole chart for threading metric screws, and that's the actual center drill hole size that you need to do, and then the rest is clearance. So it's just you subtracting the size of the threading from the actual size of the screw. Metric is pretty simple. Most of them is just, if it's an M8, it's 8 millimeters. Okay, now I'm just going to show y'all how to make the drawing. I'm just using 3D Shaper because it's really easy, at least to me. And I recommend it as like a first CAD program, but if you really think you're going to do animatronics as like a profession, I really recommend you learn Fusion 360. It seems like the best option for this type of thing. And it even can do a lot of the CNCing if you get into like 4 or 5 axis CNCing. All the drawing is just showing them what you really want them to do. They are in China, so they do not speak English, or at least most of them do not speak English. So this is just kind of like the universal language of engineering. And I'm just going to show them what size thread I want and the original through hole size. I just want to make sure y'all understand that I'm not doing this perfectly. I am self-taught. I haven't had any formal education yet. I am just starting classes in automated manufacturing, and that will put me in a lot better place. Hopefully, after I get my associate's degree, I could do a master's in mechanical engineering, and I think that would be probably my long-term goal. But for now, I've taught myself enough to kind of get it done. Okay, now it's just time to export the 3D model itself. It's important to use STEP and not STL. STEP is more of a professional format of 3D model. STL, I think, is less accurate, but it is a lot easier to use in some cases. Okay, now it's time to actually pay for the part itself. I'm using JLPCB. Before I was using PCBWay, but Gavin told me about JLPCB. Gavin, I talked about in the last video, he's Cray Ferbs or Cray-mation. He's a really cool guy, really smart, and thank you for telling me about this. It's a lot cheaper and a lot faster than PCBWay. It really has never been this easy to have parts machined. All you need to do to have things tapped is just insert the drawing so they know what you want tapped, and it's as easy as that. Okay, now it's time to design the perfect lever for the base rotation. I already know I want a 3-inch cylinder and a 60-degree rotation. For this, I use a hypotenuse of a triangle calculator. I set it to one angle and one length. I did on angle A 60 degrees because that's the rotation I want, and on length C I did 3 inches because that's about the size of the cylinder stroke I want to use. And all you need to do to find the perfect length of the lever was look at side length A. It was about 66 millimeters. And I just want to thank Kanan or PTT RAE fan for teaching me how to do this. I've known you for a long time and you're just super fucking smart. When you use the length, you want to do it from the center point. I know everyone probably understands that, but some people it might not just make immediate sense to them. So I want to make sure y'all really grasp that. And I don't know the center point of the rod end that I have for the cylinder that I ordered. I just ordered a new old stock one because I'm trying to be cheap, but I could have bought a new one and really already had that, but you know, fuck it. I'm going to be cheap with this. I'm not made of money. Also, not everything needs to be machined in China. I have my own desktop CNC machine. It's a Jinimitsu 3030 CNC machine, and I already upgraded the router. This part I'm going to machine myself just because it's really simple. I really wanted to use it more, but it ends up taking so long to cut properly that it's kind of worth it just to order from China, at least for the bigger parts. By the next video, I'll have the part in and I'll finish up this model and I'll show you how to actually CNC it using Candle, which is the online CNC control software I use. I recommend it. It's a lot easier than a lot of the other stuff, but I might have just not been able to figure out how to get the other stuff working. I did have my friend Wilson with me trying to figure it out, and it just was kind of overly complicated. It's a big change from what I'm used to, which is just 3D printing, which is super user-friendly. Especially with my new Bamboo, it's just so fucking easy. The new A1 minis, I think they're called, are like $200 right now. If you don't have a 3D printer, I really recommend it as your first 3D printer. My friend Wilson has one. He fucking loves it. He's able to do multicolored parts. He's able to have it in his dorm, and he lives out of state. Like, he moved out of state, and he has it in his dorm, and it was able to survive the drive, and just, it works perfectly. I really recommend it. I have the X1, and it works perfectly for me. Okay, we're pretty much at the end of the video. If you like it, please like and subscribe. If you have any further questions, just ask me in the comments, and then in the next video, if I can't answer it in the comments, I'll answer it in the video itself. Love y'all. I'll see y'all later.